Okay, good day, ladies and gentlemen. So, this is my tutorial on stoichiometric analysis and stoichiometric conversions. Okay, so before we start, I'd like to lay out a few steps outlined in our scientific method or scientific process, if you will, to help guide us in solving our problems. Okay, so first is identify the problem. When we want to identify what we want to do or what the problem demands of us. Next is we need to identify what information is given to us. And with all of that information recorded, we can then solve, record, and then finally conclude the problem. I said with all that said and done, let's start with our analysis or conversion. So let's start with number one. Step number one is identification of the problem. So let's read the question. How many carbon atoms are present in 8.97 grams of ethane? So it says here that we're going to start with 8.97 grams of ethane. Now, ethane is chemical formula C2H6, and it wants us, or the problem wants us to convert it to carbon atoms. So just simply write it down, carbon atoms. And then for step 2, we identify the given. So we start with 8.97 grams of C2H6 or ethane. And then this problem also gives us the information for our first conversion, which is the molar mass of ethane, which in any case we still have to solve. So let's start with carbon and then your hydrogen. Your carbon is atomic weight 12. You multiply it by 2 since there are 2 atoms of carbon in your ethane. Gives us a total of 24. And then your hydrogen is atomic weight 1. Since we have 6, it gives us a total of 6. You add carbon and hydrogen, you have 30 grams per mole of our substance. Now that we have identified all of our given and that we have clearly identified our problem, we can now move on to step number 3, which is solving. Now before we solve, I'd like to give you an additional tip to prevent mistakes, to prevent any further miscalculations. We write a simple flowchart of our process of conversion. So since we are given grams of A, here is where we're going to start. So C2H6, and then we want to convert that to our particles of B, which is carbon. Let's put a little legend here so you don't get confused. A is C2H6, and then your B is carbon. Okay. So as you can see in this diagram, there is no direct conversion between grams of A or C2H6 to your particles of B. So that cannot be done. So we have to first convert our grams of A to moles of A, moles of A to moles of B, and then moles of B finally to our particles of B. But then another tip I'd like to give you is that whenever you are given a problem that starts not with a mole, it means you're starting with particles of A or grams of A, the first thing you should always do, and the first logical step, will always be to convert it first to moles. Because as you can see and as demonstrated by this diagram, the one or the unit of measurement with the most mobility would always be your moles. Since your moles can go to particles of A, it can go to moles of B, and it could also go to grams of A. Whereas all the other units of measurement, particles of A, grams of A, can only move to moles. So that should be automatic. If you are not given moles, convert your unit to moles first before you move on to any other conversion. Okay, so let's lay out, back to the problem, let's lay out our flowchart of conversion. So we start with grams of A, which is your ethane. We convert it to moles of A, which is still ethane. And then let's change color here since we're going to be converting it to grams or moles of B rather. And then we want to convert that finally to our atoms of B, which is carbon. Okay. Now that we have our flow chart, the next thing you have to do to solve your problem is to clearly indicate our conversion factors. So what I like to do is just under the arrows, I like to write the conversion factors for each of those conversions. So in this case, grams of A to moles of A, I'm going to use the molar mass, which is 30 grams of ethane is equal to 1 mole of ethane. For moles of A to moles of B, I'm going to use, as our diagram suggests, the formula subscripts. In this case, in 1 mole of your C2H6 or your ethane, there are 2 moles of carbon. So in that case, I'm going to write 1 mole of ethane is equal to 2 moles of carbon. Where did I get 1? Each of our formulae is assumed to have a coefficient of 1. So in 1 unit of our ethane, there is 2 units of carbon. So for 1 mole of ethane, you have 2 moles of carbon. And now that you have your moles of carbon, you can convert it. And the conversion factor would be 1 mole of carbon is equal to 6.02 times 10 raised to the power of 23 atoms of carbon. Okay. And now that we have our conversion factors, we can finally solve for our problem. Now let's start with our conversion. Let's write 8.97. This is our starting point, grams of C2H6. Now, in setting up your computation, you should always remember that the unit you want to cancel should always end up at the bottom. So in this case, we want to cancel grams of C2H6, and the unit you want to retain should always end up at the top. So that would be mole of your C2H6. And once you have that set up, all you have to do is get your conversion factor, input it to the formula, in this case 30 grams, and then 1 mole at the top. Next conversion is we want to cancel your mole of ethane. So like I said, you put the unit you want to cancel at the bottom. So you put mole of ethane here, C2H6, and then you want the unit you want to retain, which is 2 moles of carbon, at the top. So you put moles of carbon. You simply get the conversion factor again, input it to the formula. So you have 1 mole at the bottom, 2 moles at the top. You got your bottom canceled out, and then repeat. So since you wanna cancel moles of carbon this time, you put it at the bottom. And since you want to retain atoms of carbon at the top, and then simply get the conversion factor, input it to the formula. So you have 1 mole of carbon at the bottom, and then 6.02 times 10 raised to the power of 23 at the top. Input that in your scientific calculator, and you get 3.60 times 10 raised to the power of 23 atoms of carbon. Okay, so notes to remember is that make sure that your conversion factors should always end up on top or below the other. It should never cross your formulae. It should never cross the multiplication sign. Okay, so as you can see, you have this set up here, you have this set up here, and then you have this finally set up at the end. Sorry, you have this set up at the end. Okay, and that would help you in making sure that you have the right conversion factors. And then once you input that in your calculator, you're very sure, or at least a lot more sure, in your answers. Okay, so next is we record this as our final answer. And finally, number 5, we get to conclude. We just simply have to say, get the problem, say, in 8.97 grams of ethane, there are 3.60 times 10 raised to the power of 23 carbon atoms. And that is simply your interpretation. So that has been your stoichiometric analysis or stoichiometric conversion guide. I hope this has helped some of you, most of you rather. At least one, I'd be happy. So I hope that answered some of your questions. And if you have more questions, feel free to comment down below or in the video. And I'll be happy to answer them once I get to the video. So thank you very much and keep being interested in learning.